Myself, Dr. Sivabalan, Professor and Head, Department of Naval Architecture. So today we are going to discuss a topic, stable equilibrium. So what is equilibrium? Equilibrium means net effect or net the forces which is acting on the vessel or the any object all are balanced. That is the equilibrium condition. So force equilibrium. So there are three types of equilibriums are there. Maybe the vessel may be, I'm talking about the vessel. The vessel may be in a stable equilibrium condition, or it may be an unstable equilibrium condition, or it may be a neutral equilibrium condition. Today we are going to discuss about the stable equilibrium condition of the vessel. So before getting to the topic, so first we will discuss what are the important things or what are the parameters or basic things are required to define the stable equilibrium or discuss about the stable equilibrium that we are going to the beginning of this lecture. First, we are going to discuss about the center of gravity of the vessel. The center of gravity of the vessel or center of gravity of the object means the total weight where it is concentrated. That point is called as center of gravity of the vessel. So here there is a figure, transverse section of the vessel is shown. So the blue color represents the load line of the vessel. There is a point is G. That point is called the center of gravity of the vessel. So through the center of gravity, there is a force, there is a weight force which is acting towards the downward direction of the vessel. So that force is called a weight force. It is acting towards the center of gravity of the vessel or center of gravity of the object. So this center of gravity remain in the same position. It won't move up and down or in the port side or the starboard side. So for a particular loading condition. The vessel may mostly it will travel at a same loading condition for a particular voyage almost. So in that case, the center of gravity remains in the same position, particular loading condition is considered. So next is the meta center. The meta center is represented by M. So what is the meta center? So before going to the meta center, there is a term called buoyancy. So what is buoyancy? Buoyancy is force, the upward force which is acting in the vertical direction from the bottom of the vessel. Okay, it is acting towards the vertical direction. So this net effect of the buoyancy force where it is acting, the resultant force where it is acting, that point is called as center of buoyancy. Okay. So this center of buoyancy basically depends on the buoyancy force, means the upward force. So this center of buoyancy may be shifted towards the port side or it may be shifted to the starboard side, depends on the sea condition or the external force which is acting on the vessel. Okay. So in this figure, the buoyancy is shifted to assume it is shifted to the port side. The center of buoyancy shifted to port side, and we are getting a different line of action. From the initially there was a line of action. It is passing through the central line of the vessel. Now you are getting different line of action. These different line of action intersecting at a point. That point is called as meta center of the vessel. Now we have defined the center of gravity and the meta center. Now we'll move on to the metacentric height. Okay, this metacentric height means it is a vertical height between the center of gravity to the meta center. You know what is center of gravity, you know what is meta center. So this vertical height between the center of gravity to meta center, it is called as metacentric height. So this position, the gap or the vertical height between the center of gravity to meta center may change. Okay, it may change due to the buoyancy force. So we have seen that the buoyancy force position will change. Okay, the line of action will change. So the meta center where the intersection also may change. So the G to M position always is a changeable one. So for a particular condition or a particular buoyancy condition. Sometimes the loading, if you are loading in a different way. For example, if you are loading the weighted cargo at the top of the vessel, then G position will rise from its position. So then the metacentric height, GM position, GM gap or GM metacentric height may be get reduced. So this GM plays an important role for a stable equilibrium of the vessel. Okay. So already we have discussed the center of gravity remain in the same position for a loading condition. The center of buoyancy, initially it was with the line of action of the vessel, means that is center line of the vessel, may be shifted due to the external force which is acting on the vessel. For example, initially the position of the center of gravity may be at B. It may be shifted to the position called B1. Okay, because of that, there is a new intersection. There is an intersection we are getting. That intersection is called as metacenter. So now we are getting a center of metacentric height. Now the vessel, assume that the vessel is shifted, the line of action shifted from the port side to, from the center line to port side. Now it has to come back. How it will come back means there is a moment will be generated on the vessel. This moment will bring back the vessel to its original position. What is the value of the moment? Basically, the moment means the force into perpendicular distance. So here we have to take the total light weight and the total dead weight of the vessel. So that will add together, that is called W, into the gap between the line of action, that is the vertical perpendicular gap between the line of actions, that is the G set. So this G set and W plays a major role. So it will bring back the vessel to its original condition. So this is called, the G set is called as a righting lever. So the total moment is called righting moment. This moment will bring back the vessel to the original condition, from the heeled condition to its original position. Okay, this is an important factor here. So this moment value, righting moment value, purely depends on the G set value, because G set is a variable here. So displacement or the total weight of the vessel is a constant for a particular loading condition. So it depends on the G set value, the vessel will back to its original condition in a particular time period. So now we'll move to the stable equilibrium, physical meaning of the stable equilibrium. We have seen that there are two forces. One is the downward direction and another one is the upward direction. Downward direction force is the weight force which is acting through the center of gravity of the vessel, and the upward force which is acting through the center of buoyancy of the vessel, and it is acting towards the upward direction. There are two forces, a gap of G's. So that will form a couple here. Okay, there are two force component and is between the gap. Okay, so that gap is G set. Basically, the two force values should be same. Then only the vessel or the floating body will freely float on the water. So here the total, in the case that weight force is equal to the buoyancy force. So two equal and opposite forces are acting on a body with a sort of gap. That system is called as coupled. Okay. So this couple will support or it will capsize the vessel. In a case of the stable equilibrium, this couple will support the vessel to back to its original position. As per this diagram, so the vessel heeled to, assume that the vessel is heeled to the port side. What the couple will do means it will act in the anti-clockwise direction. It will bring back the vessel to its original condition. Bring back the vessel to original condition. The coupled direction is in the anti-clockwise direction. So as per this diagram, it will bring back the vessel to its original position. So now the vessel will come back to original position, means that is again is a stable condition. So initially the vessel is in the stable condition. It was disturbed by the external medium, external force factor. It will go to an unstable condition. Again it will back to its original condition by means of righting moment. How the righting moment will play here, that is shown as a couple. So this coupled force will bring back the vessel to its original condition. So means that the vessel should be in the stable equilibrium. Okay, so the stable equilibrium means after disturbance, the vessel has to come back to its original condition by means of the coupled system. And the GM should be, another important thing is GM should be positive for the stable equilibrium. Then only the vessel will be back to its original position, the couple will be act, or couple will support the vessel to back to its original position. Okay, that's all about the stable equilibrium. Thank you.